Okay. Now I have shared these documents. Now, first one that we will cover would be how we are going to automate SAP 2000 with Python. Okay. Now, as of now, I know maybe there are some of you who like do not like programming, or in fact, let's say who hates programming, and there are others who has now got some experience. Right now, as of now, you have learned how to use the terminal for Python implementations, as well as how to generate codes by vibe coding. Right, on the first day we covered that, and also how to use Jupyter notebooks. Okay, now nowadays Python, generating Python code is nothing difficult, right? Only it would be difficult would be to write the codes by USL, right? That was the custom approach earlier. Now today I'll take one step ahead, and because we are looking at the structural applications, we will see how we can use this Python interface or Python based interface to interact with SAP 2000, and how we can do so many things that we cannot do in a conventional manual click by click approach. Okay. So here, one key thing to learn or to get to be aware first is this open application programming interface, or simply I will refer to it as OAPI, or simply API of SAP 2000, and how we will be using that to access through Python to do various things in SAP 2000. Okay. So that's the gist of the session, the first session of today. And the second session, I will I will explain how we can use AI agents like Cloud AI to interact with a software like SAP 2000. Okay. And that once again is from this OAPI, right? So that is why I thought of starting with this, and then we can navigate to the Cloud AI. Okay. Right. Now, yeah, just to give you a small recap on the things that you might know, might know and might not know, would be just the flow of this. Right now, we will first take a step and see what is this automation and why we need it, and how we are going to use Python for that, and how we are going to set up everything, and how we can run maybe a couple of scripts just to check whether it works properly, and how we can build models. That means assign material properties, session properties, geometries, loading, boundary conditions, combinations, right? You know all of it. How we can do it using this pipeline. And then, right, you might wonder, why do we need these things if we are following a ML or machine learning related course, right? This is where it will be very important, right? If you are looking at ML applications, you need data, okay? And to create data, we'll be using this pipeline, right? So overnight, you can create 1,000, 2,000 models, depending on the complexity. And also, if you want to look at some value engineering, it can be optimization or performing some parametric studies to find the optimal, let's say, combination of some parameters. This is another advantage, right? So that is not only to do with machine learning, but definitely for machine learning, these things are very important. Okay. So we will look at all of these things, how we can look at each and every aspect in the workflow I'm going to explain to you. Okay. Right. Now, why is it important to automate structural analysis? Now, conventionally, we do this click by click-based GUI approach, right? Now, that is, I think, I think all of you are exposed to that. And if you want to create one model, you have to make hundreds or thousands of clicks. Okay. However, right, these manual things now with all of these computational tools, we can make things automated, and I don't need to explain the benefits you are going to get, right? So I think that is obvious. The only bottleneck is how to do it. And once you get used to this, you will I'm sure you will make the best out of it in your professional or even in your studies, undergraduate or postgraduate. Okay. And this is the workflow we are going to follow in the first session on this Python build with SAP 2000. And yeah, these are the different advantages. I will not spend too much time on these because you can easily understand something that you do manually versus something if you have scripted, right? If you want 1,000 data or 1,000 models to be done, right? Manually, it is impossible. Okay, so this is why these things are important to know. And yeah, where we are heading towards would be this. Okay. However, in addition to this, right, there are so many other advantages of learning this type of scripted automation in software like SAP 2000. Okay, so I'm repeating, it is not only applicable for SAP 2000. One thing is we are focusing on structural engineering in this session, and also this is one of the software that we have full license to, right, publicly teach you. Okay, that's why we are using SAP 2000. Okay. Now, there are two basic things we have to understand properly. One is called the OAPI, right? Open API, and something called COM, right? COM. So we will see how these things will get together to give you this integrated automated platform. Now I will not go into the history of this, right? So this is you can think of it as a linking between a programming language and a software like SAP 2000. That's the job of an API. So here, open APIs. So the word open means that the company or the CSI, the owner of SAP 2000, they have it open so people can access the API. Some software they don't allow it, right, for various reasons, but software like SAP 2000, we have that benefit. Okay, so that's the idea here that you need to understand. Okay. Now, in a nutshell, this is what we are going to do, right? Because we have on the left hand side, it's the engineer or the engineering student with Python, right? We will try to make a call to SAP 2000, right? Simple analogy. And this telephone line would be this OAPI that we are going to set up in our computer. Okay, so this is entirely on the computer, right? You can't do it on a browser or anything. So you have to have the correct tools set up in the machine itself. And if you remember, I think you might have come across these words when you use SAP 2000, right? Or ETABS even. The application itself is given this keyword, or this is like a specific word or syntax. And the model, whatever the model that we are working on, let it be a trust model frame, right? That is a SAP model. And various properties. If it is a point object, we are looking at a node, right, with some coordinates and some connectivity. Right? Frame objects, I don't need to explain these, right? If it is a beam or a column, any truss member, this is a frame object. And if you have any shells or 2D elements, let's say a shell, plate, membrane, it will be an area object. And there are other things like properties of materials, sections, and so on. And then you are loading, right? For structural engineering, loading and boundary conditions are also within this. And the analysis part is here. And then the results, and then you can export the results to a form that you like. Okay, now this is the object hierarchy that we are trying to understand through the Python interface. Now, what is COM or COM is a component object model, right? Simply you can think of it as the Python is connecting to a COM as a client. Okay, so for every object, right, we learned the object earlier. Your Python script will give you a command, and through OAPI, the COM interface will be the connecting link between the two. And then it will connect it to the SAP 2000 engine or the finite element solver, and you can obtain the answers accordingly. Okay, now I'll be rushing through these slides because the slides are quite elaborative, so you can have a look even later. But what I want to show is how it is done in a Python environment, sort of a practical. So I will explain this quickly. And yeah, so these are some codes that I have included in your slides. So you can quickly copy paste and run it later, right? Not within the class. And if you are not very familiar with Python, how it works, right? So I have given you the simple code to type in. Okay. I hope you know what the command prompt is or the terminal is. So you just type pip install com types. Okay. So that is where the CI, it is recommended for the CSI applications like SAP 2000. Okay. So these I will explain in bulk when we look at the practical applications, but I have mentioned it for completeness of the slides, right? So you can follow the story. And this is once again for completeness, because I don't expect to teach you Python here, but these are some of the basics of Python that you need to be aware. Different types of variables with the number, strings with the, what is a list, dictionary, or what is a for loop. Once again, you don't need to type these codes, but just have an idea. So if some error comes in, you might be able to check that without the help of AI. You can do it with the help of AI as well, but in certain cases, it might be beneficial if you have some idea about this. But having said that, even without any idea, you can still get the things done. Okay. Now, for example, if you want to create, let's say, 10,000 models, right, you have to go for a loop. Okay? So as the name implies, loop, right, it can do iterative calculations. And one classic loop would be something like a fill. I have created a couple of spans, right? Let's say it's a uh, building with some heights. And if I want to run some simulations for different spans with different heights, right, I can use a nested for loop. Okay, for every span, for every height, I can run this simulation. That's a simple idea, and that would be important to note. Okay, and also how you define a function in Python, these things, right? I don't want to explain it in detail, but for anyone who is not very familiar with this, the lecture notes are given, right, for you to do a self-learning exercise. Okay, and how to install this type of libraries, okay, and how it is given, right, documented in the slides. So whenever you want to install these libraries like NumPy and Pandas, the codes are given. So that is basically to set up your environment, and also that will be used to handle data, right? Whether you are doing some calculations, right, solving matrices and so on. But for our context, right, just knowing these things is enough. You don't need to really use it in our calculations. Okay. Now, how we set up the machine, right? These are some of the things that I recommend for you to have in mind. Okay. Now, we, as of my knowledge, it works only on Windows, right? I'm not sure about the iOS. And you have to have Python. I'm sure you have it already. This is not mandatory as of now. These are mandatory, right? The libraries to work with. This is also not mandatory because it is mainly looking at machine learning applications. And of course, we have to have this. This is a editor. I think even Jupyter Notebook would do the same thing, right? This is another graphical interface editor for Python, and this is mandatory, right? Where it bridges up to 1,000, and these are some other libraries for plotting, sampling, statistical things, right? So that is also useful. And yeah, so you have learned these things as well. Just to give you the full picture, but in my explanations, I will not use all of these, and I will tell you why in the next few slides. Okay. Right now, first thing, you have to install all of these. Okay. Maybe your Python has already installed these things, but the simple idea is, right, pip install. These are the different things that we looked at earlier. Okay. So it will take maybe 1 minute or 2 minutes based on the internet connection. And you can just install everything in one command. So all these libraries will be installed in your Python. Okay. And we will check these things. So if you want to verify whether that bridge is connected or bridge is established, right, you can run this and you can check whether this com bridge is installed, right? So we have not linked it yet, but whether it is installed, you can check using this code snippet. Okay. And in our first run troubleshooting, right, all these issues can come. Okay. Now, one common issue would be something like this: no module name com types. That means that package is not installed. So you have to fix it using this command. Okay. But I think with the current use of AI, my advice is always use an AI agent, ChatGPT or Claude AI. You can just copy paste the error that you are getting, and then it will tell you what code I should be using to fix it. We just copy paste it in the terminal, and that would do. Okay, so some of these things I will show you when you look at the practical in a little while. But these are the common issues that you might get. So that's why I have documented it here. But it doesn't mean that there can be other errors as well, right? So keep that in mind as well. And yeah, so as I showed earlier, these are some of the objects that I have listed here. Right? We have looked at this earlier. These terms are very important, especially the capital letters, simple letters. You have to give it as it is. And I will show you how these can be generated from AI as well. So you don't need to really worry about the capital letters and simple letters, okay? Because AI knows all of these. And yeah, so if I explain something, right, now let's say we want to add a frame object. It will use this command from Python, add by coordinates. You just need to give the two coordinates of the two ends of the coordinates, sorry, two ends of the frame object by coordinates, right? X, Y, Z coordinates. And if you want to define a frame property, right, this is the command set I section for beams. Like if you want to define a UB section or I section for a particular beam, right, you can use this type of set I section commands. Okay. So once again, these things you don't need to remember anything. You can just get these things from AI. So this is just to make you aware. If you read through some codes, plenty of these will be printed. So if you wonder why, this is where to look at what this really means, right? You can see the run analysis. And if you want to obtain some joint displacements, right, axial forces, bending moments, there are commands, right, more than this for sure. Right, and usual practices in our coding, right, this return code. So in my the codes that I'm going to share you, if something is success, it will return 0. Okay, and if something is not successful, it will give you a non-zero number. Usually it is 1. Okay, now I will share you the codes a bit later, but when I show you the codes in the practical session, it will be evident to you. Usually I have this type of return codes. Okay, then it will tell you something has gone wrong. That means if it returns something other than 0, that means SAP has rejected the frame. So something is wrong with that frame creation in your SAP 2000. Then you have to check and see whether you can fix it. Okay, so these are some programming habits that you have to get used to. But as I said, if you tell the AI, okay, I have to have a return code, then it will do it for you. Okay, simple as that. And there are some other things, right? The units. Now we know, right? The first thing what we do when we open SAP 2000 like software, we will set the units to usually for our metric system, right? Kilonewton, meters, and Celsius. And that is given in this particular keyword or the syntax with command 6. Right? Does this 6 mean or means that the kilonewton, comma, meter, comma, Celsius is a sixth entry of that particular present units, right? So if you remember, there are various units in your SAP 2000. So this is the sixth entry. Okay. And also how you extract the results. Right? You can get it like U1 to R3, right? U1, U2, U3, R1, R2, R3. I hope all of you know what it is, right? U refers to a displacement where R refers to a rotation. P refers to axial loads, compression or tension. V, shear, and M for bending. Right? Anyone who is not familiar with these codes, I know there can be others who are using some other software, unlike so not SAP 2000. For those, right? This is how the commands look like in SAP 2000. Okay. Right now, okay, what I can do is we will quickly have a look at one of these applications. Right now, give me a couple of seconds to share one of such codes. Okay, now first thing I would do is to show you the PowerShell or the terminal we call it. Okay, so open. Okay, now if you can see this right now, this is the directory I am working on. I hope I don't need you to remember these codes, but since I am working on these, I sort of remember these, right? So if you want to change it, you can give the command with change directory space to some other folder. And now if I want to go back, I will go cd double dot, and I want to go back to this again. And this is a terminal that I'll be giving some codes, right? So you can use the Jupyter Notebook or any other platform that you learned from. I think Dr. Pasindu told you that. But here I will stick to this because I want some of you who are preferring this type of applications to know this as well. Okay. Right. And then I will share with you a text file, which is the Python file, which will which is quite detailed. I will share those things later to you as well. But I just want to know this right now. I hope you can, yeah, see the text file. So now there are so many. I know you don't get scared because it's too long. It basically does nothing, but it will just open SAP 2000 and close SAP 2000, right? Just to check whether everything is working, right? The connection test. Now, once again, don't get scared because most of these are print commands, right? You can see when I double click on print, right? Most of these are print commands just to check whether everything is working well. Okay, so you can see there are so many print commands. That's why it is 100 plus lines long. But if not, you can write it this within less than 10 or maximum 20 lines. Okay, so this what I can do is now I will share the full screen. Right now I can go to the terminal, and how I run a Python file on this library is I give Python space the name of the file, right? So I have it starting with A, and if I press tab, I will get that file name. Okay, so this is to check whether my Python is integrated with SAP 2000. So it will open SAP 2000 and close it automatically, right? So let's give it a try. So because of all these printing commands, it will give you a stepwise process or progress of your Python code, right? I hope now you can see the SAP 2000 is being opened. Right? So now it is opened, and if I go back, now it is closing, right? Now you can see what are the things it did. So first, it started with the API helper, right? Now just to set the background, right? The helper of SAP 2000. And then it created the SAP 2000 object, right? That is what we learned earlier. And then started the software or SAP 2000, and it connected to SAP model, right? One of like the basic interface. And then new model, right? We didn't specifically say whether it's a beam or a truss or anything, just one initialization of a model. And it created a blank model, okay? And it tells you, right? Because we gave the command print if we can see it, right? So now we actually saw it and how it got opened, and it waited for 5 seconds just to uh, show us that it worked, and then it closed, right? So I get a return code saying just sub 2000 closed properly. Okay, so our stage one test is just to check whether our system works. So it will summarize what has gone or what has happened successfully, and if there are any issues that it will report. Okay, so if it is reported, right, what I would do now, let's say this is an error, so I will just select this, right, with the mouse point. You can just select it and then copy and then paste it in the chat GPT or Cloud AI, and it will tell me, okay, this is something wrong in your system, so please input this code, and then you just need to input it somewhere here. Okay, now let's say if I want to check the Python version, right? Now this I know, I will get it. I know this one, sorry, because I'm used to it. But if you just ask AI to do it, you can get the Python version, and it will tell me what the version is. Okay. So likewise, this code, if you don't know how to find the Python version, you can simply ask ChatGPT or Cloud AI, what is the syntax I should input if I want to know the version of Python, and then copy it and paste it, and that's it. Okay. So I know when you look at these screens, you might be scared, okay, we have to go back to programming, which we hated a while ago, right? So that is not the case. So this is these things are now beyond our programming knowledge, I would say. It doesn't mean that you don't need to know anything about programming, but at least know how a program works, right? How variables are defined and loops are done. That's it. And the syntaxes can be generated by AI. Okay, right. Now, for a second example, what I would show you would be this. Now I have a Warren truss, right? I hope all of you know what a Warren truss is. And I have created another code for a Warren truss generation through this Python interface. Now this is that code. So once again, you can see loads of print commands are in here. But what it does is, right now you can see, okay, now let me quickly show you some of the things. Hope you can zoom in. And now, okay, whenever you have a truss or a beam, right, what are the things that you need to have? You have to define a material. Okay. How do I select materials? Now, SAP model, right, I told you about this keyword. And in that model, I have to define a material. And the keyword is prop material and set material. This is very similar to add material when you click on the GUI. And then I will give it S355. Okay, so usually this number one, right, refers to the return code. Okay, and if you want to give any different numbers, right, you can add that as well. So for this one, I'm using the standard or the template numbers of these properties. Okay, and if you want, you can input other properties as well, and likewise you can define. Now if it is a trial section, now this is an I section, and I think that was uh, IPE 300. So if you use it in the GUI, right, you have to first select the material. Now I have defined the material as 355, and what is this? The height, and this is the width of the top flange or the bottom flange, and this is the thickness. And if I remember, this is the root radii, if I remember correctly, and this is the width of the other flange, right? So this is basically equal flange I section, and this is another thickness value. Okay, so these are already set up in the software itself. So even if you generate from an AI tool, this is generated from an AI tool. Okay, so I didn't type these numbers. It is taken. So when I say IPE 300, any AI agent would know what are the properties of these, right? So likewise, I'll be defining the coordinates. Okay, so just give the coordinates. So I know in a Python interface, you don't need to give these numbers like this. Okay, but because it's a very trivial first example that we are looking at, I have included it in here. But what is the other approach that you can take? Iteratively or algorithm based on the algorithm that you define, you can create these nodes. Okay. Now in this particular what you call the warrant trust, I have 5 nodes in the bottom code and 4 nodes in the top code. Okay, and the distance between each node is 3 meters, and this is basically 3 sine 60, right? The height of your truss, that is your z coordinate, right? So y coordinate is 0 in all of this. And yeah, so you can define your point objects, and you will define the nodes, and then you have to create the members, right? Now we do all this, right? When you draw the member, you will click from one node to the other, and this is connecting B1 node to B2 node, and the property is a code. So this code, let me show you where I define this. This is a section property I defined for the code section. Okay, so this code is defined like this property that we looked at earlier, and the other property is web, right? So if you take a warrant truss, we have this, right? So if we have a warrant truss like this, right? So these members are the web members, right? And these are the codes, top code and the bottom code. So I have not differentiated the top and bottom, but I'm using the same section. Right? Likewise, I have released the M2 and M3, and I hope you know why, because in our pin jointed trusses, we have to consider all the joints as pin joints. Okay, so this is how the AI tells me how SAP 2000 understands this. Okay, now this is, I hope you can remember these things. This is basically M2 and M3 that I will release. Okay, so it will be a pinned truss. Otherwise, if we don't do it, the connections would be fixed by default. So this is basically the partial fixity that we change. And the support conditions, right? It will define the support conditions for the left-hand side and the right-hand side. And load. So self-weight multiplier, I have set it 0 just for comparison purposes. Okay, and usually it should not be set to 0 because we can't set dead weight to 0. And I have defined some loading. So here, this is right, fx, fy, fz, and these are the moments. Okay, so I'm defining 100 kilonewton in the vertically downward direction, or the minus z direction. And if I remember correctly, there are 3 of such loads applied at the bottom code nodes. Okay, and it defines also these partial safety factors 1.35, which is nothing new to you. And then you can select some ULS results and compare it with some manual calculations or some extractions and so on. Okay, right. Now I will do 2 things now. Okay, now I will do the first thing here. Now what I did here is to teach you how to generate this type of codes, right? Now what I did, I gave ChatGPT a simple instruction about my warrant truss and asked it to generate a reasonable prompt that SAP 2000 OAPI will understand to create that particular Python code. Okay, so this is what ChatGPT gave me, right? You can do this in other as well. And that is what exactly ChatGPT used to create this particular Python code. Okay, so in simple English, I gave that I want to create a warrant truss of this dimension in the bottom code, top code, height is this, and the material is steel, and it systematically gave the geometry first, support conditions, the connections are pinned, the loading conditions, material sections, analysis, and how it is extracted or extracting the results, and some programming requirements. Okay. For example, now, how to set the units, right? I didn't even mention that to ChatGPT, but it already accounts for that because these things are now nothing like magic, right? These things are like common knowledge to any AI agent now. And when I copy paste this in ChatGPT and asking it to generate, it has generated. Okay. Now, because this is a teaching exercise, I have separated it into sections and I have specifically asked ChatGPT to do it. Okay. And that is how I got this generated. Okay. Right now, yeah, the second thing I wanted to tell you is, yeah, so this is basically a summary of the model, right? What it actually did. So these things also, I didn't type anything here. I did some modifications, but not of this level. Okay. And yeah, now what we can do, I can, yeah, let me share the full screen. So let's see whether that our example B or the second example of, yeah, not this one. I think it is, let me quickly get the file name so I can copy paste it. So it is B Warren Trust. Yeah. Yes. Yeah. So I didn't give the extension. Right. So I have shared the full screen. So it will show you when how it opens the SAP 2000. Okay. Now it finished analysis, right? Completely analysis, complete depth analysis. Now, because all these print commands, it is easier for me to explain to you. But in your actual models, you don't need to have this type of very lengthy print condition of print commands. Okay. Now, first it will check whether it is connect that the COM connection is successful, right? It is, and then you can see all these return codes, right? Now, return codes, if it is zero, no problem. That means it is successful. But if it is not zero, then it will give you what is the error. So my advice: go back to an AI agent and find the issue. And then the material definition, right, is just checking whether it is done correctly. Sorry. And then we have two sections, file sections, web and code. And then it will create the nodes and it is printing everything. And the Warren Trust members are being created by connecting the codes, sorry, the nodes to the corresponding nodes. And then this is the partial fixity, how it applies the hinges or the pin connections at the member ends. And then it will apply the boundary conditions for the entire truss. That is one side of you have a pin support, the other side you have a roller support. And the dead load pattern, but as I told you earlier, this should not be set to zero, but this is for comparison purposes, analytical calculations. You have to do it. And this is these are the three loads that I applied, right? So there are three middle nodes at the bottom code. So I applied 100 kilonewtons each, and it is returned zero. That means it has been successfully applied. And yeah, it gives you a summary as well on the model. And then it creates one combination, which is once again not structurally sensible, but this is a teaching exercise. So I didn't really look into at the win loads and live loads. And the model is saved to this location. Okay. And it is running. Analysis is completed. So there are no errors that it reported. There may be some warnings, but for analysis completion, the warnings sometimes do not affect, right? There can be some warnings we have to check, obviously, but certain warnings are not very harmful. And I instructed it to generate the summary of results, right? With the axis force. Do it for reaction forces, right? The bending moments if it's a different problem. Now, one of the main things, right, in general, right, now with these AI and things, earlier people rely entirely on the software, right? Now this is a side story, but now people are trying to rely always on AI. Now, what is the problem? Now, this issue is that even when we teach undergraduates, they completely rely on the software results, and we repeat saying that you have to validate, validate, validate. And to make things much worse with the AI, even software, what it does, we don't see. We are just interacting through a chat bot, right? Simply, we can say that we are giving some instructions in English or Sinhala, and we just let get the results. Now, this is where you have to always, right? Always have the fundamentals right. Okay. Now, in this growing AI to technology, right? In my opinion, the need for the fundamental knowledge is never have been this important in this AI age. Right. So for this problem, you can simply apply the fundamentals, right? That is nothing difficult. You know how to solve a trust problem and what is a bottom code value, right? Now, in this case, what was our load for the bottom? Sorry, for the, yeah, now our total load was 300 times 1.35, right? 1.35, and the reaction would be this. And this reaction, if you take the, what you call it, so it would be sine 60. If you multiply this by sine 60, you will get the value of your first web code, that is your T1 B1 connection. So let's see, T1 B1 connection. This is the first web code. This is 233. Right? That is basically in one end, we have the reaction force here, and this is the compression that I am applying. Right. So this is under tension. So this force you can manually calculate by finding the equilibrium here. Right. That is a fundamental. And for any other, right, I'm repeating, these things are not very important for this type of simple examples. You know how these fundamentals get applied. But if it is a very complicated bending moment envelope, once again, you should be able to defend, okay, whatever the AI gave me is fundamentally correct. This moment value is correct. So that fundamental knowledge is far more superior now compared to our earlier days where we at least saw the software and we did the software clicking and things, right? But now we don't do that part, right? In a way that we have become lazy, but still the fundamental knowledge is far more important. Okay, right, now cutting that extra explanation, right? Now the model is saved, right? So if you want to go and have a look, you can open the SAP 2000 and see as well. And it is instructing me, it is open for visual inspection. You are required to verify whether these things have been done. Okay, and that is exactly what we are going to do, because even though we created something out of nowhere, we don't know whether it has done the job properly. Okay, now this is the truss it created. So the starting with the boundary conditions, this is pinned, this is a roller support, and just check whether the units, right? Units you can see kilonewton meters, and let's look at this member, right? So it is a code, right? Section property is correct, and the moments are released, and location. The length is 3 meters. That is correct. That is what I already asked it to do. and loads none, right? And what is, let's say we want to display something, let's say some element assigns of the frame. Okay, now if you want to see the partial fixities, and now you can see the partial fixities have been assigned properly. Okay, for every member, you can see the two green dots. That is the partial fixity, and we have removed M2 and M3. Okay, so here there is the graphical representation that you can check. And let's see whether we have defined the materials correctly. So this is S355 we defined, and you can see the properties are, at least they look about right. And we can also go and check the section properties. So it has created this code, right? Now this is what I explained to you earlier about the dimensions in meters. And yeah, okay. So these properties, that looks okay, and the material is already selected as correct. And web also you can do that check. And then we can go to the load patterns where the self-weight multiply is set to 0, and the only pattern we have is dead. And combinations, right? You can see that is also looks about right. And yeah, I think that's basically what we gave as in. Sorry, I have to check the loads as well. Let's say object loads on joints, whether we have it correctly. Right now you can see right now these numbers at 100 kilonewton has been applied in the correct direction, and the magnitude is also right. And let's go back. Yeah, likewise, you can do all this checking, and needless to say, this design aspect also you can do in SAP 2000. Once again, you can do it in the Python environment, right? No need to do it manually here. But for this example, I did not make things complicated. I just set it like this. And then, yeah, I can quickly run it. And then maybe have a look at yeah, the warnings in the uh, Y direction. You can safely ignore, and I can select the ULS, and I want to look at the axial forces, and can show the values. And these are values that the table that I have shown in the terminal, it extracted for this particular scenario. Okay. And yeah, so if you want to check the moment 3-3, right, you are not getting any moments, right? That is correct, because we have released all the uh, ends of the every member, so we don't need to check the what you call the moments, because it should be 0. Once again, that is fundamental knowledge you have to have. Okay, now yeah, that is about it, right? Okay, now I think yeah, we nearly reached about, yeah, about nearly 1 hour. Now, are there any questions in the chat? Let me check. Yeah, so please either you can directly speak to the mic or use the chat to send in any questions. Yeah, there's a question. What is a proper way to modify the model without overwriting the same model file using Python? I think that is what we just covered. So if you want to put it on a loop, right, you can make that for loop in your Python, right? That maybe I will explain it in this way. Now, let's say I want to investigate how these forces will change. For example, now this angle is 60 degrees, right? For a bridge, let's say the minimum headroom you need is, let's say 4 meters or 5 meters. And you want to check the effect of that with this angle, right? So you can tell software my angle should be varying from 45. These are not practical values, maybe 45 to a value, let's say 60 degrees. And accordingly tell me what is the orientation of the members so that certain members can be having low forces, right? So this is obvious. We don't need to do a simulation for this, but we know how to get this. But you can do that variable or parametric studies even wherein this spans. So as of now, we have the span as 12 meters, right? We can check how for a different application, how this can be uh, extended if your expected span is 12 meter to 20 meters. Okay. And correct prompt to the AI. So there's a question on correct prompt to the AI, and that is something I am also learning. But with my experience, what you need to tell AI is how you do it if you are going to click things. Okay. Now, in a SAP 2000 or any analysis software, right, we mainly have three stages. I hope you are aware of now. First stage is pre-processing. Second is processing, and the third is post-processing. Okay. Now, what is pre-processing? This is where you will give the inputs, right? We can simply call it inputs. It can be starting from geometry, and we will define some materials. It can be what you call it, sections, the geometry part of sections as well. And then your boundary conditions and your loading, combinations, patterns, cases, all of it. And then processing, usually as of now, we learn or we do only linear analysis, which is not very true for our cases. But as of now, let's stick to that. And post processing, you extract, let's say, displacements, rotations, and yeah, you need bending moments, shear forces, right? So this process you have to first know by yourself, and then tell the chat GPT or any software like that to do this prompting. Okay, now I will show you in my second session. I will tell you like some sample codes that I usually practice, but the best thing is give uh, AI the chance to generate the code for you. Okay, now you can do a quick iteration on that as well. Okay, so the best thing is to check. Now, let's say I'm using the chat GPT. Now, the best way to learn how to prompt is ask the agent itself how to or how my prompt should look like. Right now, I can just ask like, what is the efficient prompt to give SAP 2000 OAPI plus Python interface to, yeah, even though there are typing mistakes, usually chat agents don't really mind to create, let's say, a 3D truss list steps in order. And you can tell, okay, assume I am a beginner to, I don't know, Python sub 2000, maybe you are learning it for the first time, and maybe even for AI agents, right? You can just mention, and you can also mention I am a second year undergrad in civil engineering and so on. Okay. So it will give me some guidance. Right now I didn't mention anything about the materials or anything, so it will tell me, okay, master prompt. So this is like sort of a general prompt that it will give you, right? But it is better if you can specify some details as well. But here it is giving you a complete code, right? And some of these things are not really important right now. This is for you if you, because it is assuming as a student, right? So you have to, it will give you first what is a trust, and then what are the members that you have to look into. So likewise, you can learn how this is using the logic to to flow the sub 2000 interface. Right now, none of these things are important in our application. Okay. Now, what I can do instead is to tell on this, right? Let's see whether I have it. No. Mm, give me the full prompt for a Warren truss of bottom code 12 meters, top code 9 meters, member of 3 meters, and so on, right? Now, yeah, let me check whether I have another file on this, so it'll be easier to explain. Yeah, let me quickly check if I have it. Yeah, give me a minute. I just need to sign into my other account. So I can show you the codes that I have given rather than just typing it in. Okay, now yeah, I found it in my other account. Now to create what I showed to you earlier, right? On check in the interface, whether it is working, right? I showed you as the first one earlier. So how SAP 2000 and Python interface, whether it is working or not, just to open SAP 2000 and to close it. Okay. Now, here also you can mention that you are a beginner in Python, so it will generate quite a comprehensive document, so you can read and understand each and every line. So what I gave is this command, you can see, and it will give me some instructions, and it will give me a test script, right? So this is what I started and modify this slightly just to check whether it is working. Okay. Now you can see the Python code is generated right across many lines once again because of these printing instructions. Okay, and yeah, so you can. It will also tell you okay what is stage one, and I can just tell okay start stage one, stage two, and so on. Okay, and then it will give you that particular code. So you need to copy paste it to your file and then run it in your interface. Okay, that's the idea. Okay, any other questions? About the software, you can use the trial version also, right? Until you get used to it, and then see whether this can be done on the trial version. I'm sure you can. And if you don't have the license and if you're unable to find one, then you have to look at open source software as well, right? And those are also working in a very similar manner. Okay, right. And okay, any other questions before we move on to the next part where we can, yeah, you can make a skill in Claude. When you look at my second session, how we can automate the SAP 2000 link with Claude. Okay. So those, because now, even though I have been using the word Claude AI a couple of times, I am using it because I find it useful, but I'm sure there can be other chat or AI agents as well that will do the same thing. Okay, so my convenience, I'm using Claude AI, but yeah, that is not a mandatory uh, requirement for you to use. Okay, right. So any other questions? So linking SAP 2000 Python, I have explained earlier on the slides that I have shared. Okay, so there you can look at those. So when we looked at the what you call the example, then only I shifted to the software, but the linking part is in even in the recording you can find it. I will share the recording. Okay, it's about installing the different packages and then connecting with the com that I explained. Right now, there's a question on hand sketch of a truss. I will do very similar example in the second session. Okay, right. Now we have to move forward. Right. Okay, shall we do this now? Because if I start the second session, which is also very important and interesting, we'll not have time for a break. So shall we take a quick 10 minutes break, right? So now it is 10 past 10. So in 10 minutes, I will continue with the second session and we will go at 10:20 until 12 o'clock in one stretch. Okay, so take a good break and come back in 10 minutes, please. All right. I have a question on this. How SAP 2000 OAPI is connected to Python is from this. Right? I explained this to you for anyone who missed it out. See is the connection, right? It will make with the installation of the COM types, right? That is a SAP 2000 bridge. And in the first file, I will share that Python code I shared with you just to, I didn't do this one, but I just opened SAP 2000 and close SAP 2000 just to check whether it is working or not. Okay, so that's the idea. All right. Okay. Now, what we can do is now we will look at the second part of today's session, that is on this. Okay. But before moving on to this, now with the Python interface, even without Cloud AI, right, you can generate a lot of data, and you can also use it for various applications, right? So it can be for machine learning applications, or it can be for any parametric studies. The simplest idea is if you get that Python code right, you can just run it overnight, right? Maybe by 9 p.m. you start the loop to create 1,000 models and to extract some results and tabulate. And then when you wake up next day, there'll be 1,000 models run and everything saved into your Excel file or anything. Okay, and then you can just use that. That's what I think as one of the uh, strengths of that connection. Okay, right now for the second part, I have shared this document already with you. Right, how we connect an AI agent. So this one I am using Cloud AI to SAP 2000. Okay, right now what I would do is I have created a recording just in case if we lose out on power. uh, that happened yesterday. So I will share that, and it will be half an hour, and then we will discuss anything that you have as doubts. Okay, so I will do that. And in the meantime, I will share those two Python codes and one text file on that chat GPT prompt in the group, so you can also learn from that. Okay, but first let me share the recording. Hello everyone. In this video, I'll be explaining how to connect the Cloud AI with a software like SAP 2000. So it doesn't need to be always SAP 2000, but it can be a software that reveals the API, and then we will see how we can implement it for SAP 2000. As most of the software under CSI, this is a possibility. So I'm using Cloud AI just to explain how this can be done, and there are other software that you also can use, especially the AI software that you can use a simple chat to get a work done. Okay, so in this document, it's a very comprehensive guideline for anyone. So I prepared this for undergraduate teaching, assuming most of would be undergraduates, or most of you have no programming experience. Okay, and I will quickly go through each and every step here and how we can building this link. So we can just give a chat message or chat input to Cloud AI, and it will link with SAP 2000, and it will do the job for you. That you can do the modeling, you can do the analysis, you can do the design, and also you can do any optimization required by a simple voice message or a chat message. Okay, right now you can see if you look at the contents, right? What is the purpose of this, and what are the advantages? I don't need to explain the advantages. I think you can easily understand how these things can be beneficial. And starting from how to install Python, right? I know you have covered this already under this course, but this document is sustained, so you can basically refer to this document and get things done. And for any troubles or troubleshooting, there are some guidance also on this. Okay? Right. Now, what are we trying to build and how does it really work? Okay, so if you are the engineer or the undergraduate or the postgraduate, right, trying to connect to SAP 2000, our usual or conventional method would be we will do series of clicks and inputs, and then it will, that is a usual way of doing this. Okay, but now what I try to bypass is we will give our inputs to the cloud AI or the cloud desktop version of the AI app, and it will work with what we call as a SAP 2000 MCP server. Okay, so there is something like a translator that will translate your input through the AI to the SAP 2000, and it will communicate what is required through the OAPI of SAP 2000, and we are going to build up these links so that we will be able to directly work with Cloud AI to connect with SAP 2000. So this building this link is what I'm going to discuss in this particular session. Now, to put everything in a summary, we need only 4 things to do. Okay, mainly 4. Number 1 is we have to install Python and something called UV. I will explain that later. And the Cloud desktop or the Cloud AI desktop app. And then we will do some changes to one file called this Cloud desktop config JSON file. Or some people pronounce it as JSON. Right? The idea is that it will be like a text file that you will do a small edit and then we can set up everything. Okay. And there are some prerequisites that you have to. It is better that if you can have these things on your laptop, right? Because this is not a browser-based technique, so you have to have your computer. So you have to have a Windows 10 or 11 OS and SAP 2000 installed version, preferably a newer version where it is OAPI comes with the license, and also it is an updated version, so you can do things that you cannot do in earlier older versions. Okay, and if you have the SAP 2000, that's enough. This is naturally embedded into that, and then to install software, right? You have to have the administrative rights and a proper internet connection, and also a cloud account. Even a free account is fine, right? That's all good. And then how to open a terminal, right? Now, a couple of you might remember this as a command prompt or the terminal. So simply, this is what I mean by the terminal, right? So we can see on the shared screen, this is a PowerShell that Windows has. So we will be using this to give some inputs. And this is something you can find in this start. If you type terminal, you can find this terminal. Okay. And to install Python, right? I have already installed Python on this, and you know how to do it. Dr. Nihaj and the others also covered this before. And you can quickly check what is the Python version, right? So these commands might not be familiar to you, but I have given everything, so you don't need to worry about anything, right? So Python version, it gives you 3.14.5. Okay? So this is just for guidance. So there are later versions that this. And the next one is to install UV. Okay, I will not go into the details of what this is doing and what is the difference between UV and UVX, but just the tool that will connect with the SAP 2000 and do the translation between Cloud AI and the SAP 2000, right, with the MCP server. Okay, and what you need to do is you need to download and install the UV. So this you can provide in your terminal, right? I have done it already. And I will quickly check, or I will give you a quick check on this. It is UV version. You can see this, right? So it is 0.11.14, and if I type in UX also, it will be the same because this is sort of coupled. Okay, and if I go back to the document, so that is installation of UV and UVX by simple. Right, so what you need to do is just copy and paste it on the terminal, and it will do the installation for you. Okay. Even if it does not work, right, that error message, you can come back to Cloud AI desktop app. Right now, I didn't show you what is the Cloud AI desktop app. This is the Cloud AI desktop app that I'm talking about. Okay, so if you get any errors in your installation, just copy paste and just tell that what you're trying to do, and then it will give you, okay, this might be because of this setting in your computer, so you better do it like this, right? I guess for every one of you, the computers, right, their settings will be definitely different. So I can't give you the solution, but I can give you a general solution that will work. But if there's anything that you need to like troubleshoot, you can always do it on this. Okay. And to test a translator or the SAP 2000 translator, you can just run this line and check whether it works. Right? So that is not a mandatory one, but it is recommended so that you know before we connect Cloud AI, at least this SAP 2000 translator is working with UV. Okay. And what is the meaning of this? It's given, right? Run a Python tool for me, right? Because that is where Python connects to SAP 2000 in this translation business. Okay, and there's a long list of the meaning of these codes. So if you want further details, you can read through. Okay, and to get SAP 2000 ready, right? I hope all of you are now familiar with the SAP 2000. So it has an interface like this. So I have given a new window, right? So I will show you that as well. Because to work with Cloud AI, you have to have SAP 2000 opened. Okay, you don't need to do anything. It will automatically access the SAP 2000, but it does not have the administrative rights to open the SAP 2000 software. So you have to do it for Cloud AI, and then it will operate on that without any issues. So I will give just a blank model that just like what I had earlier. Okay, because whenever you are using Cloud AI with SAP 2000, you have to have this opened in the background. You can just minimize it, no problem, but you have to have it opened. Okay, so that is this step. Okay, and then you can install the Cloud desktop. Right, I have given the download link, but just one Google search away, you can download and install Cloud desktop and sign into your Cloud account with a free account. We don't need to get the pro version or the premium. I have for my other purposes, but you can still work with the free version. No problem on that. Okay. Right now, this is an important part. Now, we have established the Python access through UV to connect SAP 2000, the translation part. But now we are going to look at this SAP 2000 connector with Cloud AI. Okay. Now this is where we need to find this particular file. Where should I go and look at it? This is very important. You go to Cloud AI, and there are, I hope you can see my mouse pointer. There are these three lines that you can look at under your account. Go to settings. And under settings, there's a long list of things that you can change, but I'll be looking at the developer. And here you can see as of now, I have the SAP 2000 MCP installed, or it says running here. Okay. So what I want to show you is to go to the edit config, and it will forward me automatically to this particular file. Right now, this is what I showed in the document as well. It's called the Cloud Desktop Config JSON file. And as of now, you can see it is something that you don't really understand if you're not a computer person. So the simple idea is you can just open it as a text file. So I will open it as a text file, and this is what that JSON file looks like. Okay, so this is in my computer. So for you, this part might be slightly different because we did not add this part yet on your computers. Okay, now that is exactly what we are going to do next. But most importantly, follow this step. Right, I will tell you that again. Right, you go to the developer settings, and then you can see the other things here, right? That I will not detail a lot. So here extensions you can use for other software, and the extensions even for browsers and so on. But developer, and then you go to edit config, and then it will lead to that desktop config JSON file. Okay, and now let's exit from here. And then it tells you delete everything in that file, right? So what did I have in that file? And so you can see if I scroll down, there are so many other things that when we run Cloud AI, it will be automatically adding into, but you can delete everything and you can save with this particular command, right? It is broken into two, but don't mind. You can copy paste the entire thing. So it will look something like this. Okay? Only this top part. The bottom parts are not really required, but be mindful about these brackets, right? Whatever the open brackets should be closed. So this bracket is right at the end of the file. Okay, so this is what you need to be careful. Otherwise, it will not properly work. Okay, and then you have to fully quit Cloud Desktop. Okay, now what is the meaning of fully closing? It is not closing using this particular cross. Okay, you have to go to this. I hope you are able to see, and this is where you will close it from or quit it from, or even you can go to the task manager and quit it. And then once you open it, you will see if everything has worked well. You will see in this plus sign, if you click it, go to connectors, you will see this SAP 2000 MCP. Okay, and where else do I get other things? Right now you can see I am using the Cloud extension in Google Chrome as well, the browser extension. So it will also show me here, right? If I want, I can deactivate, but as of now it is activated, and that's what exactly we need, right? So if you have not done this configuration properly, you will not see this MCP, SAP 2000 MCP in here. Okay, so I will repeat. You go to the plus sign and go to connectors, and you should be seeing this. Okay, right. And let's go back to the document. Now, right. So how let me quickly tell you how I got this. I think that's one thing I did not mention to you. Now, how do I get this path? This is for my computer, okay? Because I have to give the path to this installed UVX executable file. It has to always link with that, with the Python translation to SAP 2000. So you have to find this. Usually it is in this bin or the local bin folder by default. So how do you find it? The code is given, right? You have to find the source where it is located, and it will print a path like this. Okay, so you can see exactly it is a path that I had, except for this your name, right? It was my name that I had, so I will just highlight it for you. So if it is a default installation, you will get here your computer name. Okay, and that is a path you have to copy paste in your config file. Sorry. And yeah, then you can do some checking a connection status, right, whether it is working and so on. Yeah, we can just copy this and paste here and see whether it is already connected or not, right? Now, if your sub 2000 is not opened here, then it will complain that it is unable to find it. Okay. Now, as you can see, it is trying to connect. And when you're doing it for the first time, it will ask you this permission. So you have to give at least allow once so that it will do the things for you. Okay. So the connection is active, that is connected, SAP 2000 version, and window is visible. That is why I have opened it already. And yeah, so we can just give a, so this is, you can give anything other than this, right? I just have put a steel beam. Apply a 5 kilonewton per meter dead UDL. Very simple. Right, I'm talking to you live now. I think there's a connection problem. Now, am I audible and can you see the screen? Can I get a quick confirmation? Right, thank you. From a structural point of view, if you remember, right now we don't really know whether it will take the self weight into calculations because we did not mention the what you call the section, and also we did not mention about a self weight multiplier. Okay, so whatever the answer you are getting, it might not be just W with 5, and we didn't also mention about any load combinations. So if you are giving an input, it has to be a proper input. But as of now, I will not go into those details. I will just show you how it would work. Okay, so I'll just give a write message and copy paste it, and let's see what it does. And I will maybe take a split of this screen so we can get a better view of the software as well. And one important thing, when Cloud AI is working with SAP 2000, never ever do your work on SAP 2000, then it will get confused. Okay. So either you can keep it minimized or just leave it like this and work on something else, and it will access and it will do the job for you. If there are any complaints, it will do the complaints. But the idea is it will, and now you can see without any of my involvements, it refreshed the window, and on the cloud layer you can see the model is initialized and it is defining steel materials. And because I did not give a specific section, it is using this IPE 300 dimensions. So those who have experience with steel, you know what this means. So I section that is usually of 300 millimeter height. So each and every step you can read here. So if there's something that you want to change, you can just copy paste that step and then ask it to change. This is not what I want. I want something else. But that's very straightforward, and I'm sure you know how to do this already. And now you can see the right hand side model is being updated, right? And you can see the deformed shape now. And now it is trying to extract the results and do the validation, because we know the bending moment is W squared over 8 at the midspan, and the shear is reaction force at the two supports, WL over 2, and the deflection also it might take into consideration. And so the efficiency of these things, right? This is never meant to be done for simply supported beams, right? So if you want to make things more efficient, right, better give all the information it needs, because otherwise it will take time to assume things and do some idealizations and get its own definition of an analysis or idealization. Okay, and also it will depend on the computer performance as well, just like any software, and also how strong your internet connection is, because you have to have a connection, I mean, especially at the setting up space. Okay, now right now you can see the results being shared on the left hand side float AI window, and you can see the maximum bending moment values given, right? Shear. Okay, so that's basically it. I think is like the simplest example that I wanted to mention. Now you can see now this is important. Now Claude AI has no idea about sub 2000 settings, okay, but it has assumed this, or it has set, because by default the self weight multiplier is 1, but it has modified this as well because it wants to do this comparison. Okay, and you can see how it has done the verification. Right, I hope these calculations are right. I did not check, but looks about right to me. Right, on this. Okay, and it automatically saves this model to a location like this. But these things you can specify. Okay? I did not specify anything, but this is something you can easily do. Okay, now, yeah, this is the first intro to this connection, and we will see other applications in other domains of structural engineering. Okay, I hope you found this interesting, and also my important message is when you install, right, even for my case, I had some issues at the installation phase and this connection phase, but don't get discouraged or demotivated. Once you have it set up, it will be very useful, and you can do this for any other software as well, where these APIs are visible or made visible, and try to make or get used to these things, because I think this is going to be the future very soon. And so if you start learning today, right, maybe in a couple of weeks or months, you will be an expert on this. So you will be, I would call it, in par with the trends of data science and all these machine learning things. So yeah, so if you have any troubleshooting, right, it gives certain things, but my advice is don't look at these tables just like we did conventionally. Just copy paste that error to Cloud AI or any Chat GPT or anything, but give the context of what you are going to do, and then it will tell you exactly, give this code, and you just need to copy paste it in your terminal. Okay, that's it. Yeah, so further things are given here, but that you just need to go through this and follow the individual steps. Or else you can look at this recorded video, so you can try to refine your connection between SAP 2000 and Cloud AI. Okay, right. Thank you very much. Then I hope you will, by default, the right. I'm talking to you live now. I hope you got the flavor of what it is about. Now, a couple of things. Right now, in the recorded version, I did not explicitly mention about these things. Now, one thing is this. Now, when it confirms the restraints, right? This one example out of many. Now, it says this, right? And also, when you look at this particular figure on the right hand side, that is not the usual pin support we see. Any idea why that is? What is the meaning of this torsional restraint for stability? Hmm? Now, these are some things that SAP 2000 give you warnings, right? Even in the trust problem, there was a warning on that lateral stability, because we know it is the mechanics is in the two-dimensional space for 1D elements, but SAP 2000, right? It works on all three dimensions. So one thing here also, torsional restraints. Usually, when we talk about pin supports and roller supports, we do not talk about this torsion aspect, which is not really relevant. It will be zero. But for the software, it has to know that it should be restrained. Okay. Otherwise, it can indefinitely twist about itself because there is no restraint. Okay. So numerically, that is going to happen if you do not specify. But even if you do not do that, it will run with a warning. But these are things that Cloud AI even assumes, things that we do not specifically say. Okay. But that doesn't mean Cloud AI knows everything about SAP 2000. That is why our prompting and our fundamental knowledge is important, right? So whenever it gives this type of descriptions, right, don't be lazy. Read through it. Maybe there are certain things that you might have missed, or some things that SAP 2000, sorry, Cloud AI has misinterpreted. So you will not get what you need out of this. Okay. Right. So the setting up, I know it will take time for you. So that's why I set it as a recorded video. So maybe if you have any issues, we can have a maybe another session for maybe 30 minutes in our next day. But as of now, this is the most simple example, and I will show you some other examples as well. And for that, I have also another recording that I will show you. But meantime, do you have any questions that you need to get clarified before we move forward? Hello. Yeah, for other FE software, how to get the translator MCP, right? So as I explained in the recorded video, the MCP is what provides this connection. And for other software, some software, the MCP is already developed, but for some software, maybe it is not developed, right? So if you want to integrate with an AI agent, you have to have this MCP connection. And for SAP 2000, it is developed mainly because the OAPI is simply it is open. However, if it is not open, I'm not sure whether the SAP 2000, sorry, the MCP connection can be developed, right? I'm not sure. Maybe I don't know about it, but CSI, I think ETABS SAP 2000 sure, and I'm not sure about other software, right? You can simply do a search on that. That is something would be interesting if you are looking at other applications. See whether this MCP connection is developed for other software, right? In your domain, right? I know there are various backgrounds that you're coming from in civil engineering. So if you are keen to apply this to your software, see whether these things are already developed. Okay, that is important. Any other question? Right. Okay. Now there's no other question, so I will. Everyone, I thought of doing this small recording on showcasing how we can use uh, artificial intelligence tools, or simply we can call them AI tools, to make our structural engineering routine tasks automated, and specifically using AI as an agent to do the routine things on our behalf. So what I'm going to show is a very simple example that we use for our undergraduate teaching level. But the idea is for you to understand how useful these things would be even to more complicated design, analysis, and optimization problems in structural engineering. So, needless to say, this will be sort of a initiation step that would be useful for undergraduate students or postgraduate students, and maybe academics and also industry professionals who are working on this type of structural analysis, design, and optimization software. So for this one, I have used, as you can see on the screen, on the left hand side, I have Cloud AI, the desktop app. And on the right hand side, I have the SAP 2000 license version, or the academic license version at University of Moratu. And I have already typed in a small problem for a 2D warrant truss to be analyzed using SAP 2000 without no intervention from the user, but I will give the necessary inputs to the AI agent, so it will do the job for me.
and I need to definitely do some validations and verify what the agent has done on behalf of me, and also whether the results are accurate. So I will not go into those details, but I just want to show you that these things are now exist in the practice, and we have to also shift towards that as well. So this input, the interesting thing would be it can be a voice input. So simply your voice can create a SAP 2000 model, or you can do the conventional text messages or chat based modeling, or as it can be also done for images. So if you can work with structural drawings, that can be also be an input. Okay, so today I'll be looking at a text input. I have given this information of the model that I want to build. So it's basically a 2D pin jointed warrant truss. As told earlier, it is a teaching example, and certain information on the pin joints and the loading and the structure system I'm going to use, some material specific properties I have given. And for example, if I look at these material properties, I don't need to give these values to an AI agent, because if I ask it to just take the values from a given Eurocode, it can already, it has a capability of doing that. Okay. But since it is targeted towards undergraduate students as well, these values I have been explicitly given, and you can even use additional information to facilitate these inputs. And the loading, I'll be using the Eurocode 1-1 loading. And for the time being, I have not incorporated the wind loads, right, to keep the model and the problem very simple. And I have given the requirement of pin joints, and also the optimization to have the bottom, top, and web codes having at least 80% to 95% of utilization. That means the demand to capacity ratio to be at least within that region. So you can decide whether you are going to group your sections as top code, bottom code, web code, or even within that you can categorize it as top intermediate, bottom intermediate, and so on. So those details, I know I don't want to go into details here. And yeah, so on the right hand side, I have the SAP 2000 window, and I will just enter on the Cloud AI desktop app, and you will see how things would operate. And if there are additional questions, Cloud AI will cross check that with me. And yeah, so I have made the interface between the SAP 2000 and the Cloud AI. So you can see the integration now, right? You can see the mouse point is still it is automatically connecting these two, and it will take a little bit of time, so it's about waiting. And you can see how the models will get updated automatically. Right, now as you can see on the shared screens, so on the left hand side you can see that now the analysis is done, and it is now at the design stage, because before optimization it is doing some checks or member sizing checks for the preliminary analysis, and then it will be doing the optimization. So now it is being run, and you can see the details. So it has modeled, it is built in SAP 2000, and the sections have been assigned, some details of the geometry is given, and some axial forces are given. And once again, I'm repeating, I have no assurance that these values are correct. Okay, so that I have to do independent set of validation checks on these numbers. And you can check with different strategies. So that is not the part of main focus of this exercise. And if you want to do any modifications, right, you can see the saved file as well. And yeah, so now it is doing the optimization, because I instructed it to use optimized utilization ratios. So it will now look for the optimal sizes of the sections that will satisfy that the utilization ratios I have constrained this analysis into. So yeah, I can quickly show you some of the snapshots on SAP 2000. let me get the full screen of this. Now, if I go to the elevation view, right, you can see this pin support, roller supports being assigned, and there are some constraints on the lateral movement because it's only a 2D analysis. And yeah, you can check various things, right? The member lengths, whether it satisfied what I instructed it to. So I instructed it to use a 3 meter length. So I think units are all matching. And the ZD is basically 3 sine 60. So I think 2.59 is also a correct value. So likewise, you can do some sanity checks and verify these things. And even if you want to change something, once again, a voice input or a text input can change the model, and then you can extract the results. Okay, and I can maybe show you some of the results if it allows during the simulation. Should be right. You can see the axial force diagram with values. If you have to check the symmetry of the results under ULS. And you can see even this ULS is already done within that simple text input. I didn't do anything for defining the load combinations. So yeah, you can check the values whether they are symmetric in terms of the magnitudes and so on. So yeah, to me it looks like the symmetry is satisfied, and you can check by a manual calculation whether these axial forces are right or wrong. Okay, right. I hope this helped at least some of you, and you build up an interest to use this type of AI agents to make your lives much more convenient. Right. So yeah, good luck and explore new things like this. Thanks.
Right. I think once again on this screen itself, I can show you a couple of things that we usually might miss. Right now, this type of lateral restraints to avoid the instability in the lateral direction. Even though we have every member or everything on a single plane, still we have not restricted the other dimension, right? So for sub 2000, it will complain if it is not done. So that is why it automatically adds it with the help of Float AI. Okay, right. Now, are there any questions before we move on to the other example, which is also, I think, quite interesting. And let me quickly show you the problem. Right. So on the shared screen, what you can see is a simple sketch of a indeterminate frame with some dimensions. Right. I hope you can see it. Yeah. And what I have done is just I sketched it on a piece of paper, and I took a mobile photo from a mobile phone and then converted to a PDF like this, right? And you can see there are some members like vertical members, horizontal members, diagonals, and some loading applied. Vertical loads are there, and some horizontal or lateral loads are there, and some dimensions are also mentioned. Okay. Now you can see I am quite bad at sketching, right? You can see simply by visually, you can see the member length of this is not exactly this right now. These are the issues that we will anyway encounter, right? When you do a hand sketch, if you do not really adhere to a scale or a proper dimension, okay? But these things can happen because hand sketches, we don't expect it to be 100% accurate. If not, we don't need to produce those, right? We will always uh, stick to a CAD software if that is a requirement. But if these things can be given as an input, right? I know you are all familiar with inputting or giving inputs as images or any other documents to any agents or AI agents. And in this exercise, what I'm going to show you is whether these type of images can be used as inputs to our Claude AI SEP 2000 intersection. Okay. So in my next part, I'll be showing you an example of this particular frame. And yeah, let's see how it is done. Hello, everyone. So in this example, what I'm trying to do is to give an input in terms of this image. So I'm trying to convert this image into structurally important information, and then I will instruct Cloud AI to work with SAP 2000 in building the structural model or the mathematical model for further analysis and design. Okay, now, as you can see on the shared screen, there are some loads being applied to this type of joints that we can identify as nodes in our computer modeling. And there are different loads in different directions. So I don't need to explain these gravity loads and lateral loads to you. And there are some pin boundary conditions that I have given here. Let's see whether Cloud AI can identify these. And there are some bracing members, X bracings here. And there are some dimensions given. Right now, I intentionally kept this value different from this value. One thing is to check how accurate that Cloud AI can identify the handwriting, and also the scale to some level of accuracy. Right now, these things are really important in structural engineering because not always we have the luxury to do the computer models. Sometimes even a small sketch might be handy, that if you can translate it to a computer model directly without the help of or without the manual interventions. Now, yeah, so I hope the problem is clear. So my immediate next step would be to get the help of a good prompt. Okay, so as my practice, I will give first I will get some idea on the prompt with another AI, or it can be the code AI itself, right? I have given some remarks and then it develop the prompt. So what I would do is I will go to the Cloud AI and I will upload this figure. On this, I will apply, or I will insert the figure, and then I have a pre-written prompt that I developed using ChatGPT. Or you can use any similar tool for that as well. So what I've instructed is to assume that you are an AI structural engineer assistant connected to SAP 2000. Okay, so it has to have that perspective in reviewing this, and the user will be giving a 2D frame, and the first task is to analyze the image and extract some of the details as I explained to you earlier. And then to convert that extracted information and do any or do not act on it, but display that extraction so that the user can confirm whether there is any improvements to be done. Okay, and then based on the user feedback, whether the user agrees or whether he or she needs to do any further calibration, that can be done. And then once the user confirms, we can use the SAP 2000 Cloud AI, the connection, to create the SAP 2000 model or the numerical model. And even here, right now, in this problem, I have not specified any material. And that is why it's given is if known, or any sections. I have not given any section. So if I want to be more, what should I say, direct on the problem, I can specify the sections. Now, for example, if it is a steel section, I can give, okay, this member has to be, or this should be a UB section of at least this height and this width for the flange, right? So those details you can refine once you once you get used to this. But as of now, I'm still in the beginner level, right? For teaching you, that's why I did not specify those. But there is a clear extension of this type of frameworks. Okay, so now as of now, I will stick to this Opus 4.8 and then press OK. will take some time based on your computer performance as well as how strong the connections are. And also the Opus 4.8, it is for complex problems. I wouldn't call this a complex problem, but let's see how accurate and how efficient this process would be. You can see how the model is being built, and it's using some numbers for self-reference. And yeah, there are some information given as missing as well as clearly given. Right now, we can do a quick verification with the model that we have given. Right now, on the right hand side, you can see the model that I wanted to give. So the loading, if you check 70, 80, 100, 180 looks about right, and 50 kilonewton lateral load. And the dimensions 3.5, 3.2, and bay 2, bay 3, the dimensions are not clear, right? So we can refine the search because for building the model, it needs that information. And also the second flow level, the edge is also missing right now. Yeah. So, but the other details are looking okay. And there are some information, right? Some information that you can believe, and also some information with some question marks, right? That has to get some input from the user. Now, there are certain things that it needs our confirmation. So, okay. So what I would do is for the first one, it is using the same number system. I will ask use the scale of the image, right? So that's basically to use the same scale for the other members as well. For finding the bay width. And number 2, follow 1, right? Because it will do the same. Number 3, I can give anything. So I can mention use structural steel S355 from N1993 1-1. Can specify the table also, table 3.1. And number 4, sections, use UB sections for all beams and columns, which is not a popular choice, but for the time being. And circular hollow sections for bracings. Number 5, brace behavior, X bases will be modeled as single members. So I can just say yes. Supports, I can maybe do a change here. 3 pin supports. So your sketch is correct. Last one on the right hand side must be a roller support. Right, let's see. These things, I'm just giving you the flavor of how these things should be tackled with. And now I can ask it to display the modified problem. Let's see what it will do. Now, as I mentioned in the instruction, now it is using the scale. Basically, the ink from the paper, that scale is what it is referring to. Okay, so yeah, once you are like getting used to these things, you have to either mark everything or else make sure that you provide a proper scale. Right now, these things are important. One example would be now if you are using an architectural drawing, that drawing will always have a scale, right? So then you can directly give that scale, location, and point out to Claude AI, use this scale. But in this toy problem, I did not really give a scale like we do in our other problems, but I hope the idea is clear, right? So it's basically giving the relevant information to the AI agent, so it will do the job that we need it to do. Now, while it is on the run, there's a couple of things that you need to keep in mind. Right now, when I use this type of frameworks, I always have a separate set of I would call documents to document the prompts that I give. Because if it is a routine task, one thing is in Claude AI, you can define a routine task. That's a separate thing. Or else you can keep some Word documents or any text documents so that you don't need to repeat the same thing over and over again. Okay. There may be certain things that are problem specific, but whether it is a column beam in a tower or a building or a warehouse, right, at the end of the day, the mechanics would be the same, right? Pretty much the same. So those information that you have to repeat should be minimized. Now, okay, now you can see some details that have been changed and also have been modified. Now you can clearly see the dimensions I have marked 3.5 and 3.2 are taken or extracted correctly. And from the first floor to the second floor, the height from the scale, it has taken as 3.4. Okay. If I need, I can ask it to directly change it to 3.5, but I'm not doing it as of now. And the scale, right? Because when I did the sketch, I didn't really bother about the scale because I want it to identify. Right now, you can see it has picked the scale in a way that three bays are different. But I don't need to wait until it gives it. I could have marked it on the diagram, or else I could have given the instructions. All the bay widths are the same. I did not do it. That's why you can see the numbers are different. Okay, but I'm just giving you the flavor. This is how AI would work. So you have to be a smart user in this type of tools. Okay, and the roller support, you can see it has also been updated correctly, so we can move ahead and see the summary. Right now you can see there are no asterisks because now the information is sort of confirmed with those 6 questions that Claude AI asked me, so I can sort of be confident. And also the material that you can see how the data has been extracted from the instructions I have given from the Eurocode 19931-1. Okay. Now, if anyone is not familiar with this, it is very similar to what you have in the British code, right? BS 5950, right? If you're working with BS codes. Okay. Now, yeah, get rid of this. You can see what are the sections it has used, right? And what are the beams and the bracing members it has used. So now it is directly giving us, right, reply go ahead, right? Now I can just copy, paste to give it the go. And once we are on this, so on the right hand side, now I have taken the considered the SAP 2000, a blank file, and let's see how it will interact with SAP 2000 to give the required output. And for convenience, I will stick to maybe one view, so it would be easier to view the things. You can see the model is being built, and there are certain things that we expected, as well as there are things that we did not expected or we did not expect. So let's see once until it finishes the work. Now the Claudia is complaining that there are certain sections that are missing from the catalog, right? So that's something that we can expect based on the installations, right? Certain names can be different. For example, if you're using the British uh, sections, right? The notation is not just UB, it is UKB. And similarly, the hollow sections are defined as CHHF, not CHS that we usually term, right? Circle hollow sections. Yeah, just sort of cosmetic changes that we have to do, right? And this is once again, if you're working with the British sections, right, in that prompt that I asked you to develop earlier, it should always have this UK terminology, right? Otherwise, it will take more time to figure out, okay, this is not UK and this is European, and it will confuse the things. Okay. Okay. Now you can see there are some important things that it will automatically do for us. Right now,
it is telling us it has zeroed the self weight because I did not specify in my loading, right? I have given some point loads only, but I did not specify this. So once again, right, your prompting has to be improved if you are to include all of these, right? So that is why you have to be careful. Or else you can simply send in the chat, we have to consider the self weight multiply as 1. So that's the other idea. Now, yeah, so the summary of the model that is being created is given. So you have to read this, right? Because of the limited time that I am not going through each and every sentence, but it is very important for you to read and verify these things. Okay. And the assumptions made and certain notes are also given that you have to pay attention. It is mentioning about those dimensions and certain section sizes, and the different section naming that it has used, which basically giving everything that it has done in terms of the assumptions. So it's our responsibility to read them and verify them uh, without moving forward. Okay, right now there are a couple of things that are quite odd. Right now, for example, observe this. This is not usually what we can see. Now you can see at every node this type of symbol is given, which is not very common. Right now, let's inquire about that. Now, before we inquire, just go to the point, select the node, and then just right click on it. Okay. Now the location, right, coordinates should be verified. It is correct because the 6.9 in the z direction is correct. It is 3.5 plus 3.4. And assignments. Now you can see there are no constraints being applied, but there are some restraints being applied. U2, R1, and R3. Now, what is U2? U2, right, in this usual local coordinate system, it is in the out of the plane of my portal frame. R1, the two rotations R1 and R3, right? So what we need in our problem is the R2, right? That is the rotation that we expect it to have. Now, this is very important if you remember the basics, right? If you are doing a 2D analysis, you have to restrain these at some point. Now, it has been restrained at the supports, but since the information is communicated to the Cloud AI that we are doing a 2D analysis, then it has automatically assumed that all the nodes has to be or have to be restrained so that we will not get any out of the plane rotations or any displacements, right? U2, R1, R3, that's why they have been restrained. Okay. Now I can just ask that. Now, okay, that is something that we have not seen earlier. So we can ask why U2, R1, and R3 are restrained in many nodes in the model. Let's see about how the explanations would look like. So as I mentioned to you earlier, right now I have instructed to do a 2D analysis. So it has taken that fully, and now it is explaining why it is using this. Right now, as I mentioned to you, out of the 6 DOFs, right, U1, U3, and R2 are the directly important ones for this type of a 2D analysis. Okay, and that's one of the reasons that it has done that assignment. That you can either you can do these things, or you can just ask it to remove those, and it will do it. Okay, so let's say I want to remove all those restraints
except for the column basis or within bracket, I can simply say in then row the supports, as I am planning to perform a 3D analysis. Right now, certain updates have been now observed. Right now, there are no obvious restraints or constraints defined, and the support conditions will remain as it is. Okay? And we can convert it to through 3D pin as well, right? So maybe for two, I will say, yeah, do this. And in addition to that, I need to replicate this frame in Z direction. Need 5 copies at 4-meter intervals. I will give it as a positive Z direction and connect each using a suitable UKB section. Replicate all members, loads, support conditions, etc. Okay. Now, this is something that we are extending our 2D analysis to a 3D analysis that we usually do, right? We will try to come up with a very accurate representative frame, and then we will replicate it in one direction. Usually, if it is a multi-story building, we do flow level, right? So if we have typical flows, we will do one flow level very carefully and define everything, and then we will replicate along the column height direction with a column spacing, right? So here I have done it in the other way around. So I have defined it to replicate this frame in the Z direction. Now I think that is a mistake. I did should be in the Y direction, right? Now let's see. Okay, I did a mistake. Now let's see how it will prompt it, or whether it will go ahead and do it, or whether it will ask me for any clarifications. Now I will interrupt this and I will make the correction, right? Otherwise, it will take a lot of time. Okay, so I will put it as plus y direction, and then I will present. Right? Sorry about it. It's a small mistake on my end. But now you can see it has done certain things, right? Which definitely is not structurally very significant because we do not have such wind racings in the middle of a building. But I think the idea is clear to you, I guess, right? Now, because there are certain things that it will also ask me that when I mean 5 copies, that I'm referring to additional frames of 5 numbers, right? Not in total. So it will create additional 5. Therefore, in total, I have 6 frames spaced at 4 meter, right? That is 20 meters long. Okay, and then it will give you the required the summaries that you have to always verify. And these verifications are quite straightforward once you have some experience with these. Right, you can trust Cloud AI on certain things, right? That you don't need to really worry about, and only the mechanics and things you have to check. Right now, that is what I mentioned earlier. Also, now with the use of AI, the fundamental knowledge is far more important nowadays compared to the earlier days, right? Because earlier days we had some sort of an idea of structural norms when we came up with all these designs and analysis. But now, if AI is doing it for us, we have to have a very thorough grasp of the structural mechanics, analysis, and also various design aspects. Okay, and yeah, you can read through these and then just give it a rotation and see whether what you wanted to obtain has been obtained. Right now, I can see the connectivity. I didn't even mention that nodes to nodes how it should be connected. Right now, it has done it the way I need because it has structural sense. Okay. Now, yeah, that's what I wanted to explain in this example. And yeah, feel free to give your thoughts and comments about this exercise. All right. So I'm talking to you live now. So I hope you found it useful. And yeah, we have a couple of more minutes until we finish the first half of today's session. So are there any questions or anything that you would like to uh, ask from me or get clarified? Or what is the status? But I have one question, whether we can improve rebar design in concrete structures in this process, right? Now, my question is yes, because I did not explain anything about the design aspects in this case, right? But in that earlier one, right, the truss example, I told you, so I told the SAP 2000 to iteratively select me a section which is maximizing the utilization ratio, right? That is for steel. So basically, to keep at least your demand capacity ratio more than zero point 0.8 and less than 1. Okay, so that is a design decision. So similarly, when you look at concrete structures, the rebar design also you can incorporate, but you have to be right very clear with the prompting. So, for example, the initial reinforcement, uh, let's say it's a beam, right? So you have to specify. Okay, you have to calculate this as per 16 millimeter diameter, and concrete cover. All these things should be properly given, and then you have to mention about the load patterns and how to develop the bending moment envelopes with the different combinations. So those things you have to clearly give. Right now, one of the participants also mentioned about developing a skill. So in Claude, you can develop skills. I did not explain those things as it is. I did not plan it, but I can quickly show you on Claude AI how you can develop skills. Okay. Now, hope you can see now in this plus sign, you can see the skills here. Right? So as of now, I haven't got any skills developed on this, but in this, you can see, I think manage skills. You can select already developed ones. Okay, not this one. Maybe the browse skills. There are certain skills that have been already developed, right? So my advice is look at these skills. Okay, I don't know whether there are any developed structural skills, right? But you can develop. So basically, now what is a structural skill that you need to develop? Now, for example, let's say when you want to apply the beam loading, we can specify, okay, if the four edges are being supported by beams, check the aspect ratio. If it is less than 2, design it as a two-way spanning slab, or consider the loading as two-way spanning. So your beams will be loaded in that fashion. If it is not, use one-way spanning. So that you can add as a skill. So Claude will also improve upon that. And that is something that you don't need to repeat always. Okay, because that is a repetitive or routine task. If you are a structural design engineer, you can keep or develop those as a skill so that you don't need to every time ask it what to do. Okay, so those things I think are very important for you to learn and improve upon. And can we connect with AutoCAD or Revit? I haven't done it, but I have seen this AutoCAD. Sorry, this is Canva, and there's another connector, right? So you have to read these things. I can't cover everything, especially on these right now. Connectors I have used in Google Chrome, and let's say I think there was one with the AutoCAD documentation or product help. There is one, and yeah, likewise. So there are some connectors that you can directly connect without this programming thing that I did in the beginning, right? For SAP 2000 Cloud AI connection. So those are the things that people are developing. So someday soon they will develop for the SAP 2000. But as of now, these are the things that you can readily connect with Cloud AI. So you don't need to do any programming or anything. Yeah. So yeah, that is to answer that question. And yeah, I think I don't know whether if you are on my LinkedIn, I have recently shared another thing on the Cloud AI use of Google Chrome, how you can use to do various things. Right? Even to develop a website, you can use the Cloud AI Chrome extension. Right? So those things you can look up. I mean, there are so many things that you can do in addition to structural engineering. So those things would be informative. Yeah. Thank you. Yeah, any other questions or anything that you want to get clarified on these things that we discussed within the first 3 hours of today? There's a question on any drafting AI tool to draft with prompts that, again, I'm not well aware of, but there should be. I don't think because there are so many free versions right now, even in structural analysis and design, even because I'm using SAP 2000 because we have a university license, but there are plenty of software that you can find which is free of charge, right? And the one of the issues would be there are certain codes that are not having a very user-friendly user interface. So people do it, maybe if they give it free of charge, they won't spend a lot of time in developing the user interfaces, right? However, if you are keen to learn some Python, then you can connect everything and develop your own uh, platform as well, right? Similarly, now I think AI tools for drafting, right? So maybe there are enough and more software for drafting purposes, right? There you can develop a small tool for your use. That's also a possibility, or else just get the help of AI just to check whether there are any drafting software free of charge that you can use with an AI tool. That would also do. Yeah, reports can also be generated using Claude, right? Even in SAP 2000, or even if you take Procon, you can develop or you can generate comprehensive design reports. So that also you can just tell Claude AI, I want to extract design report, and it will do it for you. Okay, so looks like there are no more questions. So with that, shall we then break for lunch? So we will, Dr. Nihaj will start the afternoon session at 1 o'clock. So it will go from 1 to 4. Okay. But if you have any further questions, right, you have my WhatsApp number. I would prefer if you email it to me. Might not be very active on WhatsApp, depending on my availability. But if you can email, I will make sure I'll get back to you within a couple of days at least. Okay. WhatsApp messages I might miss. There's a high chance that I might miss, so better stick to emails. That's more than helpful. Yeah. Okay. Thank you. Then please join at 1 o'clock, and then we can finish day 4 with structures and also the construction management aspects of AI. Okay. Thank you.